Hello. So I'm finally back, and oh my god, it is so much messier at this angle. I wish I fixed that camera angle before I started recording. But hey, that's how it is. Welcome. So for today, I was supposed to record this in the morning, but right now it's 7:42. So better late than never, I guess. But we're gonna start this video off with a practice question. So I've been wanting for the past few days to actually do inverting a binary tree, and I thought it was a lot harder of a question than it is said to be. But apparently, it's a LeetCode easy. I thought it was like LeetCode medium at least, but it turns out to be less complicated than I thought. I thought it was just gonna be completely flipping the tree, and having this value to be one or something, which I realized it would be infinitely harder to do. Or wouldn't be that much harder for this problem, right? Because I think one would just be the start, and then it would kind of just turn into a linked list where everything is uh, greater than the next value, basically. That would be the way you would do it for one, I think. But that's a lot harder of a problem. And inverting a binary tree is essentially just flipping all the left nodes to be the right nodes. And it starts off. Ooh, I have the answer here. So it starts off at the top, the root value, as you would, and essentially it's going down the tree, and the moment it reaches nothing, it'll go back, and it goes to right, reaches nothing, then it goes back, and then it flips those two right values. Okay, so in this example, it would first look on the left side of 4, which is 2, and then the left side of 2, which is 1, and then look on the left side of 1, which is null, so then it goes back, and goes to the right side, checks the left again, it's null, goes back, and then now once it reaches here, it will basically just swap these two. You can get a const value or a temp value of left or right. It doesn't really matter as long as you store a temp value to um, basically have a pointer to this value once you change the left pointer. So it's just the root left becomes set to the value of the root right, and then root right is set to the temp value, and you're kind of just doing this recursively through the tree, and that's basically it. All these recursive problems are kind of just one one solution fits all. If it works on one solution, you can kind of assume that it works on every other solution. So it works in the case of 4, it works in the case of 2, and if 1 had subnodes, it would also work in that. So I already did attempt a solution of this, but I just wrote out a binary tree input in the form of a JavaScript object, the same way that the interview laid out the reverse linked list, right? Or just laid out the linked list, just because I thought it would be. I do actually kind of like doing this. Obviously, there's a lot of repetition in terms of when it comes to trees, because you're not just doing the next value, you're doing the left and the right value. You gotta make sure that both the left and the right have values, essentially. But for these smaller trees, it matters a bit less, because you can kind of assume that that's just gonna be the input size that you need to write. But for bigger ones, I would definitely reevaluate my data structure to store this tree in. But for now, a JavaScript object is fine. So let's begin with the function invert tree. Okay, and we'll get the root. And the root in this case is basically just this object. So we'll do a console.log for the error cases. For the tests, the manual testing that we're gonna do. So this should return out a flipped version of this, basically, right? Where the left becomes the right, and then this left becomes this right, and then this right becomes this left, and so on. So we start off with recursive problems. Usually it requires did I say recursive problem? Usually with solving tree problems, there's two ways you can go about it. You can go about it the graph traversal way, which is DFS and BFS, which DFS is recursive, BFS is could be done. I've never done BFS recursively, but I don't think it can be done. Usually it's you just have a queue for BFS, and then if you don't want to do it recursively for DFS, you just use a stack. And yeah, it's usually DFS is easily done recursively, but if it's not done recursively and if you're just going through the tree, recursion is fine. You don't really need a DFS recursive function, but sometimes I like to write it in some harder problems that require you to basically start from the left or the right tree, and you need logic outside of that. But in this problem, it's a lot easier, so you don't need to worry about making it an additional function. My initial solution for this was actually to have a DFS. I think it will still work actually, because the way that I did it was kind of just broken, just because I wasn't checking for null, I was checking for undefined, which normally would be fine, but in these cases, these final cases where we want it to backtrack, the value is actually set to null. So I wasn't checking null, which meant that it would actually go into these values and then it would check the left of this basically, right? So I'll just write out my solution for it before, which was if root, which is the base case, in the case that, you know, this is null, or, you know, the termination point, which is here. If root is equaled to undefined, I guess loosely is fine actually. If it was loosely typed, I think it would actually return, like, it would have actually worked. I just returned, right? And then if root dot left does not equal undefined, but for the sake of the example and to show you guys where I went wrong, and to show myself where I went wrong in the future, DFS root dot left, and then we need it for the right side as well. In this case, let me think if order matters. Order doesn't really matter. You could go right and left here. It doesn't really change the difference, because we're not really going it in any particular order. We're kind of just going down the tree and swapping them. As long as we go through both the left and the right side, it will work fine. So that's fine. And the time complexity in this for this function would be O of n, where n is elements in the tree, right? And I'll just do this function. So these are basically the iteration points for the recursion, right? So this will be the termination point, where it basically backtracks once it reaches this point, if it ever reaches this point. And this is essentially just continuing down the tree, right? And then once we go through this, we can assume that we have reached a point where the left and the right are not undefined and have reached essentially the lowest point where we can reach, right? So it wouldn't be here, it would be around here, because the left and the right have just been gone through, and reaching this point essentially means that there's no more further points in the tree, right? So now we do our swaps. So again, like I said, it doesn't really matter which element you temp, as long as you remember to switch that out for the actual value, or as long as you remember to, what am I doing? As long as you remember to switch out the value that you tempt first, because it doesn't make sense for you to switch out the other one. And then there we go, there we have it. Now this won't work because of the way that I have checked the comparisons, right? Because this is a non-type converted comparison right here. So if this is null and this does not equal, then it will return false, and it won't go into here. And in fact, I think it will still go into here, but it won't terminate because it will yeah. Anyways, I'll just show you guys. It won't work. Okay. So node practice question.js. Now it returned undefined. Ooh, I should probably. I haven't even done the thing actually. DFS root and then return root. Right. So this breaks because it's going to a point where root is actually null and it's not terminating, and that's because of this triple equals, and that's because there is no termination possible here. So if you get rid of the double equal, if you loosely compare it, then it will work because null is equal to undefined, double equals to undefined. So now we can have a look. So we have our initial value. The left now is, we'll compare it. The left now is 7 and the right is 2. And the left value of that is now 3 and the right value is now 1, which is the opposite of this, and this is the opposite of that. And the left is now 9 and the right is now 6. So there you go. Inverting a binary tree. It's not too bad. It's definitely a lot more work. You could do it like just straight up here, but for the sake of I guess readability and modifiability, I decided to make a function for it. And yeah, that's just the logic. You could simplify the lines here if you wanted to, but there's kind of no reason to. You know, like 3 lines converted to 2 lines isn't really that big of a difference. So there's inverting the binary tree, and that's the first 11 minutes done of this video. So now we go on to the crux of the video, which is habit lock. We're back. Finally, I have the energy and the motivation and the actual botheredness to make a video on habit lock because I desperately need habit lock. Okay, so my uni term has just restarted again, which is absolutely disgusting. I had 2 weeks break and it felt like maybe like 1 week, and now all of a sudden I'm back already, and it's already the first week is over. This is the second week, and I have been non-stop procrastinating. So this is a must-have for me right now. I needed this last week. I needed this before the uni started. Okay, this is an imperative now because I genuinely need to use this, and I genuinely will use this the moment I have it in a functioning point. Okay, so a couple of things I need before this becomes functional, and the quicker I get this done, the quicker I can kind of start prototyping it. Okay, so the first is storing persistence, is having persistence in this web extension. Okay, and how I'm planning on doing it, I'm not sure if this will even work because it implies that I can store local storage items from an extension into Chrome, which sounds like a bad case of no encapsulation, you know, because a Chrome extension should just be something that sits on top and it shouldn't really have access to the core of Chrome, right? But I'm here to test that theory by stealing the 2 functions that I have in Forget Me Not, which I use to actually store into local storage of the Chrome extension, right? And I think I'm just gonna search. It's weird because Chrome uses Chrome for a lot of their API calls, whereas Mozilla and I think a lot of other browsers actually use Window. But in this case, I think if you just ignore it and don't even say it, then it'll work. That was the case for Forget Me Not. So we're gonna definitely have to do some testing for that. So that's number 1. We need to figure out persistence, and we need to find a way to do it ASAP, basically. Because if we don't, it's gonna be very, very stupid, right? Say we had a habit lock that was currently locked, and we click lock, and now it's unlocked, right? So now it is locked, But if we close this extension and then open it back up, it's locked again. And right now, it's already in a locked state. I think I've already gone through this like a million times. I forgot what the thing was. Let's go maps. Okay, well, something is broken because it's not locking. Did I do Google? I might have done Google. Okay, let's do this. Yeah, so developer, I think it's on Google right now. So persistence is number 1. Number 2, which is kind of an extension of persistence. Number 2 is storing user inputs and user locking. And then 2.5 of that is probably going to be figuring out how to add that into the extension dynamically, right? That's what this habit setter function is, basically. It's going to be basically receiving a... yeah, there's going to be a whole bunch of mumbo jumbo about like if the user already has a bunch of to-dos, then it'll basically have... Okay, that's actually a lot. So that'll be number 3. So the first 2 things that I need to get done is definitely just storing the state that the habit locker currently is in, and number 2, storing the habits that the user has submitted. Right now we can only submit 1 habit, right? And that's fine. That's kind of what I set it to be. And once we reach other milestones for this, then we can start extending it and doing multiple words, basically. Okay. So now, let's begin. I want to at least, look, if I spend the next 30-40 minutes working on persistence of this, of the locking thing, and I get it working, I'll be happy. That's the goal for today, okay? Like, that's the bare minimum goal. And that's only if I take a long time with this. If I take maybe like 10-20 minutes on this, then I'll try and get the submit user thing working as well. Or the submit to do thing working as well. So let's begin. This actually takes some thinking because let me get re-engaged with this project because I haven't done it in a while. So let's see. Submitting this appends habit to local. This doesn't do anything right now. This is currently just a asynchronous function for some reason, even though it doesn't make any API calls. This does, but it does so locally, I believe, and there's no awaits, so there's kind of no reason for async here as well. I don't know why I have so much async. And same thing here. So none of these need async. And I don't know why I had async. Right, because I'm not making any API calls to anywhere besides Chrome itself. And I think those calls don't require awaiting. So let's get re-engaged, right? I'm repeating a lot of words because I don't want to lose my train of thought. So, in fact, no, actually that's fine. Okay. So, let's think about it in the event loop, right? We start off with set is enabled, disabled, right? So it's set to false. And then the moment we toggle the extension, we set it to the opposite of what it currently is. So right here should be the very first set item in local. Okay, if... Actually, no, it doesn't matter because set item in local and get a key, which is state. And then the value is enabled. Okay. And I'm kind of scared because I'm scared that this won't set it immediately and I'm using the old version. So what I'm actually going to do is set it to current and then is enabled. And I'm just going to flip it outside. So that way, no matter what, the state is the same. Okay? So we're going to change it no matter what. And then on startup, initially when this gets reopened, if get item from local state, if state does not equal undefined, what? Fine. Set is enabled to state. Okay. Now we can test. And yeah, I think that's actually all we need to do. So now let's check if we lock this. So now we're locked. Okay. And I'm gonna do AWD so we can search up Google. So Google is blocked. Google is unfortunately blocked. Okay. It should say unlock because currently it is false. That's a damn shame. Alright, let's console look this. Let me see what is going on. Refresh this and let's begin. So console lock. Nothing. Yep. That's fine. Close this. I want to. Oh, actually, no. It will pop up anyways, right? And it doesn't. Why don't you? Okay, I'm just gonna remove this because it's been a minute, and I am trying to think why it doesn't work, even though it should. Is that it? I honestly forgot how to set this stuff, but anyways. Does it ever enter there? Let's just console log this to check. Hello. And then refresh that. I guess update. I don't know. I think it's just refresh. Oh wow. What is going on? Huh. So it's not even entering this toggle extension, which is a bit annoying. Huh. Oh, incognito. Oh, that would be amazing. Did I do this correctly? Is this add extension to Chrome? Well, I mean, the extension's there. That's not the issue. The issue is that the console log is not displaying. Let's just change submit. Yeah, that's not changing. Well, I guess there's that. Okay. So now, 41. State is null. So does state continue to be null? No. So now we can check if the state persists, and it should say unlocked. Okay. I don't know if I needed to build there, but I think I did. So that's what the issue was. I needed to run build. So let's get rid of this and let's get rid of this, because now we have state. Oh, now we have persistent data basically. Right? So we click lock. Obviously, it'll be lock, but the best part is that that what the hell? Oh, that's because I didn't build. Okay, so that's the first part done, and that's great because now we have essentially the backbone for every persistent data storage we're gonna need for this project, you know, at least for the web. Okay, that's the only thing. This is only the case for the web, and this is the annoying part about this project. For every single device that I want to put this on, I'm gonna need to program it in a different way. It'll be the same project, but it's gonna be done slightly differently, because for Mac I need to do it Mac way. For Windows I need to do it the app way, and for that's about it. And for the web extension I need to do it the web extension way, which is probably the easiest, which is why I started on it, which is the same thing that I said when I started this. So I don't know why I'm repeating it. I'm just dumb. Okay. So that took around like 10-15 minutes. So now we want storage of to-dos. Okay. To do this, we're gonna have a div class name. Actually, I think I'm using Tailwind, right? For this? Nope, I'm not. I should, but that's fine. We'll do that later. So, for this, we can introduce habits. Set habits. Use state. So now I want a way to display my habits, essentially, right? So for now, I'm just gonna display my habit. And I need to build it again, which is fantastic. Ooh, that's not what I want happening. What is that? Oh, it's because I haven't stored this habit either. Habit. And then for the same thing, alright, submit that. Oh, whoops. it does. It updates with every single one. Does it? Yeah, it does. Oops. Okay. Card. That's good. Okay. Alright, there we go. And now we'll build this. Great. Update that. And check it out. Google. Boom. There you go. So now Google is locked. And it stays. There we go, Google. Why is it unlocked? Oh, it's because it's unlocked currently. Huh? Why is Google allowed? Oh no, it's on the wrong one again. Did I turn off the blocking? I think I might have turned off the blocking somewhere. Oh, never mind. I'm dumb. This is intended. This is intended behavior right here. So let's go. TikTok. Lock. Boom. Google is closed, but TikTok is open. Right? I don't want to show anything on TikTok because, yeah. And then you can see here it is still TikTok. So there we have it. That is exactly what I wanted. Coding. How to coding. How to start coding. And then all of these should be fine. Yeah. So that's the only problem. Which is why the next part is going to be a bit more interesting because we're going to have more than one habit that is available that you can do or that you can have at any given time. But for now, this is fine. And I will call it a day here because what? just the readme. That's fine. Okay. There we are. There we have it. Wait, that's the readme. What? Nah, I don't think so. Yeah, so there we have it. Because I want to save a bit more complex stuff in the future. Okay. That's it for today. Did some coding and worked on habit lock. And yeah, it works. Alright, see ya.